Hi, and welcome. We are Circuit Breakers Robotics from 11717 from Troy, Michigan. We'd like to share what we've learned about making a shooter flywheel. We wanted to have a system where our shooter wheels would be accurate. One variable to make our shooter accurate is to maintain the speed of the shooter wheels after each shot. To maintain the speed of the wheels even after we shot one or more discs, we wanted to add flywheel mass to the shooter wheels. Adding weights would increase the mass of the wheels, therefore allowing the wheel to lose less RPM to the ring being shot. For the first two rev grip wheels, we added half-inch bolts and nuts that totaled around a half pound per wheel. This was possible because the bolts did not interfere with the pulley or the belt. For the third grip wheel, we couldn't use the bolts because it would interfere with the pulleys and belts. Since we don't have a lathe to make a custom weight, we thought that we should become blacksmiths and pour liquid metal onto the grip wheel. To pour the Bison 60, a combination of 40% bismuth, 60% tin, into the wheel, we first had to prepare. To do this, we took an 1/8 inch aluminum sheet because it is a really good conductor of heat. Then we added pan butter grease to the aluminum for the same reason. Since this was used to prevent wheel or metal from sticking to the aluminum, any high temperature lubricant should do, but there are probably better release agents out there to use. We screwed the wheel to the aluminum sheet and placed the assembly into the freezer. This would help it cool enough when we poured the Bison 60 and hopefully not melt the plastic. After that, we started heating the Bison 60 in a ceramic mug, which was put in a toaster oven at over 400 degrees Fahrenheit. After that Bison 60 melted, we poured it into the wheel and poured cold water immediately to cool it and prevent it from warping or melting the plastic. After the wheel cooled down, we removed it from the aluminum plate and noticed that the weight distribution was unbalanced and that there were bubbles all over. We also put a little more than needed and covered a couple of screw holes to reduce the imbalance. We just drilled partial holes and reduced the mass of the particular spot. This was achieved by inserting 5mm shaft into the wheel and supporting it with a ball bearing on either end so that the heavy spot always rotated to the bottom. Then drilled just a little bit and tried again until the wheel would no longer rotate by itself. Then we thought of different ways to improve the results, such as spraying the aluminum with Teflon instead of PAM. We hypothesized that the PAM bubbled a little and created some of the imbalance. Another way to improve this process was to mount the wheels to a motor and pour the Bison 60 while the wheel was slowly spinning to make the Bison 60 balanced. We could also let it cool using air instead of pouring water and instantly cooling the metal. We also thought of using a different ratio of 88% bismuth and 12% tin we call Bison 12. This melts at an even lower temperature and will stay liquid longer, so it will hopefully have less frozen bubbles in it. In summary, this ended up being pretty successful. We added an entire pound to that one wheel and took up way less space. Next time we do this though, we will be sure to try these improvement ideas and make other videos. We will also do a video that does a deep dive into our entire shooter design and all the techniques we used. So be sure to subscribe to our channel. Thanks for watching. And please, if you have any suggestions or comments on how we can improve, We'd love to read your ideas. We are here to learn after all.